A great circle is a circle on the surface of a sphere whose plane passes through the center of the sphere. So any circle drawn on the surface of a sphere whose plane passes through the center of the sphere shall be referred to as a great circle. If you see this diagram out here of a sphere on which three great circles have been drawn, and you can see the plane of each of them passes through the center of the sphere. A great circle is the largest circle that can be drawn on any sphere, means the radius of the great circle is the largest possible for any circle that can be drawn on the surface of the sphere. Any diameter of any great circle coincides with one of the diameters of the sphere. All great circles have the same center and radius as each other, as well as that of the sphere. So that means radius and center of every great circle is same as the radius and the center of the sphere.
Okay, beta, any doubt in any of these points on this slide?
No, sir.
No, sir.
Very good. We are basically going into spherical trigonometry basics. This knowledge is enough, means required when we go into great circle problems.
All great circles have the same center and radius as each other, as well as that of the sphere. So that means radius and center of every great circle is same as the radius and the center of the sphere. For any 2 points on surface of a sphere, there shall be one and only one great circle passing through them. It means that if you take any 2 points on the surface of a sphere, there shall always be one great circle passing through them, and that shall be the only great circle. That means one and only one great circle passes through any 2 points given on the surface of the sphere, unless the exceptional condition is met. And the exceptional condition is if the pair of points or the points happen to be diametrically opposite to each other, that also referred to as antipodal points, then in that case, through those 2 points, you can draw infinite number of great circles. The minor arc of a great circle between 2 points is the shortest surface path between them. So if you travel along the surface of the sphere, then the arc along the great circle or the track along the arc of great circle shall be the shortest distance between any 2 points on the surface of the sphere.
Okay. So beta, as we see here that for any 2 points, there shall be only one great circle passing through them. The exception to this is diametrically opposite point. A very good example of these diametrically opposite points are the two poles on the Earth's surface, the North Pole and the South Pole. Now from these points, many great circles can pass through them because these are diametrically opposite points. All the meridians or longitudes which we have, 0 to 180, east or west, all these are great circles passing from both the poles. So poles are the diametrically opposite point, antipodal points, and infinite number of great circles can pass through them. If 2 points are not diametrically opposite, then there will only be a single one great circle which will pass through them. So all clear up to here, Peter?
Yes, sir.
Okay, very good.
The arc along the great circle or the track along the arc of great circle shall be the shortest distance between any 2 points on the surface of the sphere. Now let's discuss why great circle distance is the shortest distance between any 2 points on the surface of the sphere.
Now beta, I just now told you about different types of sailings. We have plane sailing, we have parallel sailing, Mercator sailing, great circle and composite sailing. Now, normally you see when you make a passage plan, the form of sailing which we use is plane and parallel sailing for a normal passage plan. Great circle sailing is only used when you are moving on a very large distance track, a interocean kind of track, crossing a particular ocean which has the distance in thousands of miles. Now, what is the reason for that? We normally do not use great circle sailing. What we use is plane and parallel sailing. Now, the reason for that is the simplicity. The plane and parallel sailing or Mercator sailing is much simpler as compared to great circle sailing. Now the question which arises in the mind is that if plane and parallel sailing is simple form of sailing, then why don't we use it always? Why we come to great circle sailing? The reason for that is great circle sailing is the one which gives us the shortest distance between any 2 points on the surface of Earth. So plane and parallel sailing or Mercator sailing may be simpler, but the distance which they give us is not the shortest distance between the 2 points. The shortest distance we can obtain only with great circle sailing. Now for smaller distances, we do not go into great circle sailing because it will be too much complicated and the saving in distance does not justify it. Let us say if you have a 100-mile track and converting to GC sailing saves you half a mile. Now saving that half a mile at the cost of making your passage plan complicated is not a good bargain. So that's why we use the simpler form of sailing for smaller distances. But when the distances becomes huge, like you are crossing an ocean, the distance is in thousands of miles. So in that case, the saving in distance is also substantial. Changing over to great circle track may save you 50 miles or so. Now 50 miles is a substantial distance to save. So that's why we use great circle sailing for longer distance. So let us now see why does great circle sailing gives us the shortest distance.
We know that the surface of the sphere is curved. So any 2 points on the surface of the sphere cannot be joined with a straight line along the surface, because surface being curved. So that means they have to be joined by an arc. Now we also know that as the radius of the arc increases, its curvature decreases. Decreasing curvature means the arc is tending closer to the straight line. So if you have an arc with the least possible curvature, then obviously along that arc, the distance shall be shortest. And we have already said that the largest possible radius of a circle on the surface of a sphere is that of a great circle. So if that is the circle with the largest possible radius, means it's a circle with minimum possible curvature, and hence the distance along a great circle between any 2 points on the surface of the sphere shall be the shortest distance as far as surface movement is concerned. Now let us quickly review the concept of spherical triangle and the formulae used for solving the spherical triangle to the extent as required for the topic.
Okay, so beta, first important concept was what is a great circle. Now after that, the second important concept is what is a spherical triangle. So if you have your notebooks, the first thing which I would like you to write down is this particular sentence. A great circle is a circle on the surface of a sphere whose plane passes through the center of the sphere. So if you wish, you can note it down in your notebooks, or if you want to take a screenshot and save on your device, it's fine with me. Just let me know once you have done.
Okay, sir.
Okay, beta, good. Okay. The second important concept which I would like you to note down is what is a spherical triangle? So just take a screenshot or you can note this down in your notebook. Done, beta?
Yes, sir.
Okay.
To the extent as required for the topic. A spherical triangle is a triangle on the surface of a sphere. So please remember it's a triangle on the surface of the sphere, every side of which is an arc of a great circle. That means if I have three great circles intersecting each other, and if the sides form a triangle where on the surface of the sphere, the triangle so formed is referred to as the spherical triangle. As you can see in this diagram, this gray shaded triangle is formed by intersection of this great circle, this one great circle, and the red great circle. So this is one of the spherical triangles so formed. Now, since it's a triangle, it has 6 parts. It has 3 angles at the vertices, and it has 3 sides. So how are these parts of the spherical triangle identified? The vertices, the names of the vertices indicate the name of the angles at the vertices, and they are represented by capital alphabets. For example, in our case, if you see on the screen, you have X, Y, and Z, which have come, and these are the vertices of the spherical triangle. And obviously, then this angle at this vertex is referred to as angle X, angle Y, and angle Z. Now, the spherical triangle also has 3 sides. Now, these 3 sides are the sides opposite to the angles. Sides are either named like XY, YZ, and ZX, or they are represented by small alphabet, same alphabet in lowercase as the one used for the opposite angle. So that means side XY is nothing. Either you can say side XY or you can represent it with small z, as you can see in the diagram. Side YZ, you can represent it by small x. And side XZ, you can represent by small y. So you can represent the sides either by using the combination of the vertices, or you can use them the opposite angle in the lower case.
Okay. So any doubts up to here, beta?
No, sir.
No, sir.
So just one small doubt.
Bolo, beta.
It has been written that every side of this spherical triangle should be the arc of a great circle.
Right.
So it is possible that a small circle like the parallel of latitude is the arc is also the part of that circle.
No, beta, no. First, let me tell you what is a small circle. See, we have seen a great circle is a circle on the surface of a sphere whose plane passes through the center of the sphere. Now, if you have any other circle whose plane does not pass through the center of the sphere, it is known as a small circle. To give you an example, if you see the equator on the Earth's surface, equator is a great circle. because the plane of the equator passes through the center of the earth. All the meridians are also great circles. A meridian and its inferior meridian or anti-meridian together form a complete great circle, like Greenwich meridian and 180-degree meridian joined together, they form a complete great circle. But the parallels of latitude other than the equator, 10 degrees north, 20 north, 30 north, and likewise the south parallels of latitude 10 south, 20 south, 40 south, 60 south. All these parallels of latitudes are small circles because their plane does not pass through the center of the earth. Now for making a spherical triangle, all the three sides have to be parts of the great circles only. If any one of the sides is part of a small circle, it does not form a spherical triangle. And we cannot use the spherical triangle formulas in that case.
Okay, sir. Thank you very much, sir. Everything well understood. Thank you, sir.
ओके बेटा, और बेटा और कोई डाउट आ रहा है अभी तक? ओके, वेरी बोलो बेटा, एनी डाउट्स? Okay, let's proceed ahead then.
Now, cosine formula is the formula which will be used for solving questions in this part of the video that we are covering.
Now we come to one of the most important formulas in spherical trigonometry and in celestial navigation as well. So this is the cosine formula. Basically हमारे पास बेटा दो important formula हैं पूरी spherical trigonometry में जिनको हम लोग celestial navigation में बहुत frequently use करते हैं. So the first one of them is the cosine formula and the second of them are the Napier's rules. So we will do the cosine formula, that is all we require for great circle sailing. When we move on to composite sailing, then I will show you the Napier's rules also. So this is a very, very important formula, not only used in great circle sailing, but also used in celestial navigation at many places. So let's try to understand this formula.
Now, what is cosine formula? I'm sure all of us know it, but let's quickly review it. Cosine formula is used for any side. So cosine of any side, x, y, or z, any of these sides, is equal to cosine of the opposite angle into sine of adjacent side 1 into sine of adjacent side 2 plus cosine of adjacent side 1 into cosine of adjacent side 2. Now let's write down the formula for all the three sides. Let's say if we write it for cosine x, if we write for the side yz or small x, then opposite angle would be x, adjacent sides would be y and z, and the above formula then can be written like cos x is equal to cosine of angle x into sine of side y into sine of side z plus cosine of side y into cosine of side z.
Okay, so did you understand this formula, beta? Cos of any angle of the spherical triangle is equal to cos of opposite side. You see, in any spherical triangle, if we consider any angle, let me make a small triangle here. So let's call it as ABC. So in this triangle, if you consider any of the angles, let's consider angle A. If I consider angle A, which will be the opposite side, beta?
Small a.
BC, sir, which
BC.
is small
Yeah,
a.
you can call it
Small a.
small a or you can call it BC, one and the same thing. That's the opposite side. And which will be the adjacent sides?
Sir,
AC
AB
and
and
AB, sir.
AC.
Very good. So AB and AC, or you can also call it small b and small c. So this formula basically tells us cos of any angle is equal to cos of opposite side minus cos of adjacent side 1 multiplied by cos of adjacent side 2 whole divided by sine of adjacent side 1 multiplied by sine of adjacent side 2. So I will send this PDF document to you. It consists of the cosine formula as well as the Napier rule. So just go through this cosine formula. Let me know if there are any doubts anywhere.
No.
Sir, if we have two angles and only one side, so can there is any formula for that also?
No, beta. Cosine formula cannot be applied in that case. If you look this formula carefully, this formula is applicable in two conditions. One is when you have all the three sides of the triangle known to you. All three sides of the triangles are known. If you see on the right hand side, we have all the sides. Opposite side, adjacent side, adjacent side, adjacent side. So if you know all the sides of the triangle, you can find any of the angles. So that is one application. The second application is if you know any two sides of the triangle are known to you, and you know the included angle also. Let us say, for example, to give you an example, let me pick up green color. Let us say we know side AB of this triangle. Side AB is known, and we know side AC of the triangle. This is known, and we know angle A. So we know two sides and the included angle. Then also the cosine formula can be used. This is the second case where the cosine formula can be used. So if you try to put it here, it will be cos of angle A is equal to cos of opposite side. In this case, the opposite side would be BC. Cos of adjacent side 1. So adjacent side would be AB and adjacent side 2 would be AC. And denominator also adjacent side 1 would be AB and adjacent side 2 would be AC. Is the application correct, beta?
Correct, sir.
Yes,
Okay.
sir.
Now if you see what is known to us, angle A is known to us, side AB is known to us, side AC is known to us, AB known, AC known. The only unknown here in this formula is this particular component, BC. So if you put the value of all other components, you can also find out what will be side Bravo Charlie or side BC. That is the only unknown side. So this is the second application of
Sir,
the Bolo beta.
this adjacent side 1 and 2, we can take either AC or AB first, no issue, no, sir?
Yes, beta, you can take any one of them. If you want to keep AC here in the front, that's perfectly fine. You can keep AC here and you can keep AB
Okay.
here. Any one of them can be taken.
Okay, sir.
Sir, my question
sir.
was that this formula is like this, no, cos any angle equal to side and side and side. So can we interchange it with cos of any side equals to cos on opposite angle minus cos of adjacent angle into cos of adjacent angle 2, like this?
Means you want to put side in place of angle and angle in place of side.
Yes, so the formula will be correct then. Means then we can use to find out any side with use of any angles.
No, beta, not possible. Cannot be done.
Sir, thank you. That was my question. I understand.
Okay, so it will be angle wherever it is mentioned this way only. We cannot interchange the angle with sides. Okay, so the same cosine formula can be represented like this also. Hmm. So it is the same formula, only thing is uh, the values have been taken onto the other side of the equation, but it is exactly the same formula. So this formula which you see in the video is also the same formula. Only thing is the values have been changed right hand side to left hand side, but the formula is exactly same. Okay, so let's continue a little bit further.
Cos y. Cos y, obviously opposite angle is capital Y and adjacent sides are small x and z. Similarly, sine of z, opposite angle would be z, adjacent sides would be small x and small y. Now, what do we see in this cosine formula, which we have just learned here and revised, in fact, out here, is that it involves three sides and one angle. So to be able to use the cosine formula, you need to know either all the three sides, then the cosine formula can be used to find the missing angle, or you should have two sides and the included angle. In that case, you can use it to find the third side. So please remember, to be able to use the cosine formula, either you should have all the three sides or you should have two sides and the included angle.
Okay, now this is very important, beta. The two conditions where cosine formula can be used. Number one is all the three sides should be known to you, or any two sides and the included angle should be known to you. So important thing here is the angle should be the included angle. So if you know a angle which is not the included angle, then in that case cosine formula will not be applicable. A doubt may arise in your mind, what is applicable then? We will see that later. Right now we won't require or we won't have that condition coming in our questions. So as far as the GC, great circle and composite circle questions are concerned, you will have one of these two conditions being asked to you. Okay, so any doubts up to
But
here, beta?
this included angle is one of the angle, no? So angle should be
Yes,
known.
beta. Let us take, say, for example, you know side XY and you know side XZ, right? If you know these two sides, which will be the included angle in that case?
Okay, sir, understood. That is x.
That would be X. So you need to know angle X. अगर आपको ये दो
Okay.
साइड्स पता है, XY और XZ पता है और आपको एंगल Y पता चल गया है, तो फिर हम कोसाइन यूज नहीं कर पाएंगे. कोसाइन फॉर्मूला विल नॉट बी यूज्ड इन दैट केस.
Okay, this included angle is the angle included between those two particular sides.
Right, beta. That is the included angle.